All right, Algebra 1, 5.5 notes, writing equations of lines. So, you're writing equations of lines, summary, slope intercept form, y equals mx plus b. So you're only going to use when you know the mx and the b, because if you don't know those two, then you're out of luck. Because y always equals 2, remember that. And then your point slope form would be a y minus...
Okay, Mr. Hunter,
y,
Mr. Hunter, Mr. Hunter.
Mr.
I think you're telling them wrong. I think you're confusing them.
Okay, well, I'm going to turn it back over to professional now. It's all yours, Mr. Yantz.
Thank you, Mr. Hunter.
You're very
Everyone, thank
welcome.
Mr. Hunter for trying to help us out here today.
Math is very important, kids. Remember that.
All right. Okay, guys, so now that Mr. Hunter is out of the room, let me actually tell you what does go in those blanks. So we've learned 3 different forms for writing the equation of a line. The first one is the slope-intercept form, and the only thing I want you to remember about that form, besides what it is that you can only write an equation in slope-intercept form when you know the slope and the y-intercept. Okay, the second form we talked about was point-slope form. Point-slope form we can use when we know either the slope and just a point on the line. It doesn't have to be the y-intercept, it can be any point on the line. Or we can use it when we know 2 points. Because if you know 2 points, remember, you can use your slope formula to calculate the slope. Finally, we've just most recently been talking about standard form. That's the form that we don't really use directly to write the equation of a line, but we do want to remember that it's very easy to find the x and y intercepts whenever you're given an equation in standard form. So in today's lesson, we're going to take all 3 of these forms and we're going to practice translating among the 3 different forms and learning how to write equations given certain information about lines using one of these 3 forms and talking about which form would be the best one to use. Okay, so let's jump down to the first set of examples here. In these examples, we're going to go from standard form to slope-intercept form. This is actually something we already did once in the last lesson when we were graphing lines in standard form. We talked about how we can change it to slope-intercept form. And basically what you're doing is you're isolating y. You want to get y by itself so that you go from this ax plus by equals c form to this form here, y equals mx plus b. And so that's going to involve 2 things for each of these equations. The first thing is going to be isolating or moving the x term over, the equal sign. So in number 1 here, I have a positive 5x minus 3y equals 15. I want to subtract 5x from both sides. That's going to leave me with negative 3y equals negative 5x plus 15. Okay, so now the x term's moved over. Now I want to get y by itself by dividing everything by the coefficient on y, which is negative 3. So I divide every term by negative 3, and I get the equation y equals, I have a negative 5 over negative 3, so that becomes positive 5/3 x, that would be the slope of this line, minus 15 divided by 3 is 5. So y equals 5/3 x minus 5 is the slope-intercept form of this line. One thing I want to point out is these are both still the same line. Okay, if you graphed both of these, you would get the exact same thing. It's just one is written in a different format than the other. One is standard form, the other is slope-intercept form. But they are indeed the same line. Okay, number 2, I'd like you to pause the video and try that one on your own. So you're writing this equation in slope-intercept form just like the last one. Once you have an answer, click play to check it, please. Okay, let's check your answer to this one. So you should have gotten the slope-intercept form y equals 2x minus 3. You had to add 6x to both sides and then divide both sides by positive 3 to get this form. Okay, moving on to the next section. This time we're going to go from slope-intercept form to standard form. So we're just going to reverse what we did in 1 and 2. We're going to start with y equals mx plus b form, and we're going to go to ax plus by equals c form. 2 things you want to remember about standard form. One thing is you can't have fractions. So the first thing we're going to do anytime we're going from another form to standard form is if there are fractions in our equation, we need to cancel them out. Okay, so cancel out fractions first of all. And then finally, x and y are on the same side in standard form. And so we're going to move both the x and the y terms to the same side of the equation. So number 3 here, I have y equals 2/3 x plus 5. Notice I do have a fraction. My slope is 2/3. So the first thing I'm going to do is cancel that out. And the way to do that is to multiply every single term by your denominator. Okay, we have a 3 down here, so I need to multiply by 3 on the left side and then by 3 on the right side. And when I multiply on the right side, I have to remember to distribute it to both those terms. So this is what I'm going to get. I'm going to get 3y equals, when I take 2/3 times 3, these 3's will cancel, and I just get 2x. So 3y equals 2x plus 5 times 3 is 15. So now I have an equation without fractions. Now what I can do is I can move my x term over to the same side as y, so I can subtract it from both sides. Subtract 2x, subtract 2x. That's going to give me negative 2x plus 3y equals positive 15. Okay, so that would be an equation in standard form. I will tell you some textbooks, just depending on which one you use in high school, will tell you that standard form makes you go a step further, and some textbooks will say that standard form requires that the x term be positive. So in some textbooks you're going to see this. You're going to see them do the same steps we did, but then you'll see them, if the x term is negative, multiply everything by -1 in order to make this positive. And so that would give you the equation 2x minus 3y equals negative 15. So just keep that in mind. Sometimes you might see this as the answer for standard form. Both of these would be correct in this class here, but you may have a teacher that requires you to make this x term here positive anytime you're writing an equation in standard form. Okay, for number 4, we have y equals negative 5x plus 10. For this equation, we don't have any fractions in it, so that first step is done for us. All we need to do is move the x term over to the left side to get it on the same side as y. We're going to do that by adding 5x. So we add 5x here, add 5x here. That gives us 5x plus y equals 10. Okay, the next section we're going to go from point-slope form to slope-intercept form. And so, again, we're going to isolate y for this form. It's going to be a little bit different process than what we did with standard form to slope-intercept form. But it's basically going to be 2 steps. To go from this y minus y sub 1 equals m times the quantity x minus x sub 1 form to y equals mx plus b, the first thing you should do is get rid of these parentheses on the right side. We're going to do that by using our distributed property. So distribute first on the right side. And then finally we're going to isolate y by adding or subtracting. So number 5 here, we have y minus 2 equals 2 times the quantity x minus 3. The first thing we want to do is distribute this 2 to get the equation y minus 2 equals 2x minus 6. From there we can isolate y by adding this 2 here on both sides. That's going to give me y equals 2x minus 4. Again, these are the exact same line, okay? These 2 equations here are referring to the exact same line. It's just that this one up here is in point-slope form. This one down here is in slope-intercept form. Okay, number 6, we have y plus 1 equals 2/3 times the quantity x plus 4. So we're going to distribute our 2/3 first. That will give us y plus 1 equals 2/3 x plus 2/3 times 4 is just 8/3. Okay, from there we're going to subtract 1 from both sides. So minus 1 here, minus 1 here. So we get y equals 2/3 x, and then 8/3 minus 1 would be the same thing as 8/3 minus 3/3, which gives you 5/3. Okay, so this would be y equals 2/3 x plus 5/3. Okay, finally, the last set of examples, we're going to do something a little bit different for these. Okay, so one thing I want to point out here, now that we're using all 3 of these forms kind of in the same lesson, I want you to remember to read carefully what information you are given, because sometimes you have to start out with one form and then change it to another in order to answer the question. And so that's what we're practicing here in 7 and 8. 7 and 8 is asking you to write the slope-intercept form of the equation. So our answers here need to be in y equals mx plus b form. Okay, that's slope-intercept form. But the only information I'm giving you is 2 points that a line is going through. Well, if you look back at the summary that we did at the very beginning of this lesson, okay, I said the only time you can use slope-intercept form is when you know the slope and the y-intercept. Okay, we don't know the slope or the y-intercept for 7 or 8. We just know 2 points. When you are given only 2 points of a line, you have to use point-slope form. Okay, so what we're going to do for number 6 and 7 is we're going to start out by, first of all, calculating the slope between the 2 points, and then we're going to use point-slope form to begin each of these problems. Okay, because I can't use slope-intercept form yet because I don't know the y-intercept. So the very first thing I need to do is figure out what my slope is for number 7 here. So I'm going to use my slope formula. M equals change in y over change in x. So my y-coordinates are -4 and +5. My x-coordinates are 6 and -3. So I'm going to get -4 minus 5, which is -9, over 6 minus -3 would be 6 plus 3, so that's +9. So my slope is -1. Okay, so now what I'm going to do is I'm going to take this slope and I'm going to choose one of these points. It doesn't matter which one you choose. You can choose either 6, -4, or you can choose -3, 5. I'm going to go ahead and take 6, -4, and I'm going to use point-slope form. So y minus y sub 1 equals x times the quantity x minus x sub 1. Okay, so my y-coordinate of this point here in blue is -4, so this would be y plus 4 equals, my slope is -1, so -1 times the quantity x, and then the x-coordinate is 6, so this would be a -6. Okay, and if the direction said write the point-slope form of the equation on the line, then we could stop right there. But the directions again say write the slope-intercept form of the equation. So now that we have the point-slope form written, we must change it to slope-intercept form. And we're going to do that by doing what we did in the previous 2 examples. We're going to distribute this -1. That's going to give us y plus 4 equals -1x plus 6. And then we'll subtract 4 from both sides. So you get y equals -x plus 2. And that is the slope-intercept form of this equation. Okay, so notice it's basically 3 different steps we're doing. Okay, the first step we're doing is we're finding the slope using our slope formula. That's step 1. The next step is we're writing the equation in point-slope form. And then after we write our point-slope form, we are isolating y to change it to slope-intercept form. Okay, one more example practicing this same thing. So number 8, we're given the points -3, -4, and 3, -2. So again, the first thing I'm going to do is I'm going to calculate the slope between each of these points. So we have a -4 and a -2 for our y-coordinates. Those are going to go on the top. So it's going to be -4 minus -2. I can change that to +2. And then -3 minus 3 on the bottom. That's going to give me -2 over -6. Which is going to become +1/3. So the slope of this line is +1/3. That's step 1. Now that I've calculated my slope, I'm going to use one of the points to write point-slope form. Okay, again, it doesn't matter. You can use the first point or the second point. This time I'll just take the second point to change it up a little bit. So I get y plus 2 equals 1/3 times the quantity x minus 3. That would be my point-slope form equation. From there, I need to distribute this 1/3. That's going to give me y plus 2 equals 1/3 x minus 1. And then finally subtract 2 from both sides, which gives me y equals 1/3 x minus 3. Okay. Alright, so that is the slope-intercept form of this equation. One more thing I want to show you really quick in this example here is I used the point, again, 3, -2, and told you it didn't matter which point I used in this step right here. So I want to think, okay, what happens if I change that point, if instead I use -3, -4? Well, let's try that and see. So I'm going to go ahead and erase what I have here. Instead of y plus 2, I'm going to just go ahead and use that second point there. I'm going to say, okay, what if I had made this y plus 4, and instead of the x minus 3, x plus 3? So what if I had used my first point up here in purple for this point slope form equation? Okay, what would happen? Well, let's take a look and see what happens. I still distribute this 1/3 through, and so instead of y plus 2 equals 1/3 x minus 1, I actually end up getting y plus 4 equals 1/3 x plus 1. Okay, so I get a little bit different work here. And then instead of subtracting 2 from both sides, I'd end up subtracting 4. But watch what happens. When I subtract 4 from both sides, I'm doing 1 minus 4 this time. I still get negative 3 for my b value. In slope-intercept form, I still get the equation y equals 1/3 x minus 3. So that's why I said it doesn't matter which point you pick up in this step 2 right here. Okay, when you're writing your equation in point-slope form, either point you pick, you're still going to get to the same slope-intercept form equation. Okay, if there are any questions over this one, feel free to email those questions to Mr. Hunter. Just kidding, email them to me, and we'll discuss this the next time I see you in class. Until then, have a nice day. You're all wonderful people. Take care.